All right, 8th grade, your next lesson is 12.2, and these are the notes over Pythagorean theorem. So our learning goal for today is to be able to use the Pythagorean theorem to determine unknown side lengths of a right triangle. So there's some vocab that we need to know. So the first one is that this Pythagorean theorem, this only applies if we have a right triangle. A right triangle meaning we have the right angle. Okay? And in our right triangle, the two shortest sides are called legs. Typically, we're going to call the very shortest leg A and the longer leg B. The longest side, which is opposite of the right angle, that makes it really easy to identify because it's always across from the right angle, is called the hypotenuse. So when we talk about the legs and the hypotenuse of a right triangle, we need to know which is which. And we'll always call the hypotenuse C. So our Pythagorean theorem says that A squared, or my shortest leg squared, plus B squared, the longer leg squared, equals C squared, or the hypotenuse squared. So in any right triangle, this is true, that the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So here's how you will use this. Always start by writing your formula, A squared plus B squared equals C squared. Next, I'm always going to substitute what I know. I know the legs in this example. I have a right triangle. That's the first thing I need to check for. And my legs are 3 and 4. And I know that those are the legs because the hypotenuse is across from the right angle. So the hypotenuse has to be this side, which is unknown at this point. So I'm going to substitute 3 in for one of the legs, 4 in for the other leg. When I square those and add them, it's going to equal the square of the hypotenuse. So I wrote my formula, I substituted, now I simplify. 3 squared means 3 times 3, which is 9, plus 4 squared, which means 4 times 4, which is 16. C squared, I still don't know. But I can continue simplifying by adding. 9 plus 16 is 25. So if 25 equals C squared, then I can use what we practiced last topic with our integer exponents topic, and I can solve this equation by taking the square root of both sides. Taking the square root will cancel my exponent of 2. Those undo each other because they're opposites, and the square root of 25 is 5. So now I know that the lengths of this triangle are 3, 4, and 5. Okay, now you are going to try this one. So we're going to start by writing the formula. A squared plus B squared equals C squared. Again, I need to check, is this a right triangle? It is, so I can use the Pythagorean theorem. Now I'm going to substitute values. So my hypotenuse, my C value, is the one that's across from my right angle, and that's the one that I don't know. So 7 and 24 are the lengths of the legs. So I can substitute 7 squared plus 24 squared, and that's going to equal the hypotenuse squared. Now I'm ready to simplify. 7 squared is 49. 24 squared is 576. And I don't know C squared yet, but I can continue simplifying by adding. And 576 plus 49 is 625. And now I can take the square root of both sides. The square root of 625 is 25, and the square root of C squared is C. All right, it is your turn to solve this third example here in your notes and enter your answer. Okay, sometimes to the nearest tenth, we're going to have to find out the length of the hypotenuse of a triangle because not every number is a perfect square. So I can still, because this is a right triangle, use a squared plus b squared equals c squared and substitute what I know. I know that I'm missing the length of my hypotenuse because this is the side that's across from the right triangle. So I substitute the lengths of my legs into the equation. And now I simplify. 6 squared means 6 times 6, which is 36, plus 11 squared, which means 11 times 11, which is 121. And I can continue simplifying by adding. So 136 plus 121 is 157. And now my last step to solve is to take the square root of both sides because that allows me to solve for c. The square root of c squared is c, but the square root of 157 gives me a decimal. So I will just round it off to the nearest tenth. The square root of 157 is 12.52. So I'm going to round it to 12.5. The last thing you will be asked to do on your homework today is looking at the slant height. So we're looking at slant heights of pyramids. So when we talk about the height of a pyramid, we are talking about, oh my goodness, dropping a point down, a line down from the vertex here straight down so that it is perpendicular to the ground. That's the height of the pyramid. The slant height would be the length of this side from the base slanting up to the very top point of our pyramid. So we can find that slant height by using the Pythagorean theorem because this forms a right angle with the ground. The height and the ground form this right angle. So I'm going to identify what information I have and what I'm looking for. This slant height is going to be my C value because it is across from the right angle, so that makes it my hypotenuse. So I'm going to use the lengths of the legs, which is 146.71, and I'm going to square it, and I'm going to add it to the length of the other leg, which is 115.175, and I'm going to square it, and that's going to give me C squared. So when I do 146 and 71/100ths squared, I get 21,523.8241, and it just keeps going. And when I take 115 and 175 thousandths and square it, I get 13,265.280, and it keeps going. So I'm going to round to the nearest hundredth. And now I can add those. And that gives me 34,789 and 1/10. And that equals C squared. So my final step is to take the square root of both sides. The square root of C squared is C. And the square root of 34,789.1 is 186.518. So I'm going to round that to 0.52. So we could say that the slant height is about 186 and 52/100ths meters in height. Now you are going to use that same process, but this time you are going to solve to the nearest tenth and find the slant height of this pyramid. I want to point out though that we know the length of this leg, but we aren't given the length of this leg. But what I do know is that this leg is halfway across the base. And I do know that the width of this base is 18.2. So the leg of this triangle stops at the very center. So this leg is going to be half of 18.2. So if I divide that in half, that gives me a length for this leg of 9.1. And you may now use your formula to solve. Your homework is digits 12.2. Good luck. I know you will do great.